Okay, let's make a new scene now to go to the new thing. So, okay, so we just made few prefabs. So I'm going to also make it into the folder. So prefabs, and bring all of these prefabs should be treated differently than the models. I will put all the imported original models in models folder, and prefabs for anything that we actually use and scaled correctly in our scenes. Prefab, and there is sphere, prefab. Okay, so we have house, sphere, and brick. Okay, let's make a new scene. Save the new scene as in the scenes folder, scene number 3, terrain for pixel reader, let's say. Okay. Well, one thing we are going to what we are going to do, let me just show you some example. Give me 1 second. How is the tutorial so far? Is everybody doing okay?
Yeah, so far so good.
So good, okay.
For me, I think my laptop just died, so I might just have to keep watching it, and I'll follow along.
Okay, okay.
Like after.
Okay. Okay, so one thing, so right now, what I'm going to introduce, let me just show you this thing. So what I'm going to introduce is this, a way to kind of understand and read the color information from a map. Yeah, so if you have whatever a terrain map, you will have some, let me just show you some other. So for example, let's say you will have some road information and some other information. Maybe you wanna have some more dedicated treatment to the site according to the color, right? So in this case, you will need to be able to read the color information from your map as an image, all right? So what I'm going to introduce is we are going to use a very colorful color to start with as an example, and bring a terrain mesh, whatever terrain, and to exercise how to read the color information and use that color information to trigger some geometric operation. Is that okay? So here in the materials folder, I'm going to drag this image. You can make an image folder. So this sample texture 3D, and in the OBJ, in the models folder, I'm going to bring that sample site OBJ model. Okay, so we are all set. We are going to bring this file here and reset the position, say F. So this is positioned somewhere here. Doesn't have to be super precise at some point. And then we are going to make a material that has this texture in it. So right click, create a material, and name it terrain color. And then we are going to drag this image to this albedo. And then drag this terrain to here. So we have a material with our image. Okay. So we are going to have, we are going to create another empty game object similar to our parametric wall. We are going to make a random geometries. So let's say random city. Let's name it random city as game object. Script, right click, create a new script called random city. And then connect it to the random city and double click or edit script.
Hey, Somi.
Mhm.
Sorry, how did you load the material or the texture? Did you just drop it in?
So you create a material called terrain color and drag that image to Arbedo and drag this material to the object.
Oh, okay. Gotcha.
Okay, so have your script ready. I'm going to delete this. We are going to still create a similar to this parametric wall. We are going to make a public public game object. We are going to name it base house. Okay. Once you save this, sorry. Okay. And we are going to create a simple house cube. We said I'm going to kind of estimate this house normally will be around like at least 4 meter by 4 meter kind of unit. Yeah, this one is underneath, so I'm going to just make the color. All right, so this will be my house prefab. It's another prefab. Simple. Maybe I can make this a little bit taller. So it's a house prefab. House simple cube house. Let's say. Okay. I'll explain you later why I use this method instead of the real house. Okay, we are going to go to the random city and bring this simple cube house to here. You can make this into prefab and then delete it and then put it there as well. We can do that. Simple cube house. And the random city became random city. We use this one and we can just delete this one in the scene. So we don't have to have it in this.
Hey, Somi, is the random city empty object?
Yes.
Okay.
There's nothing. Okay. And first of all, we are going to create some random geometries around this area. But firstly, I just want to check where is 0, 0, 0. So I'm going to make a cube object. So that's 0, 0, 0 position. And it seems like it's around the size of 100, 200. Okay, it's around the size of 180 or 160. Okay, 170 by 170. I just want to check the size. Yeah, so okay, so if we create random geometries around 170 by 170, it should be kind of safe. It will fall into this our object. All right. So we understand that. So this cube is just for size checker. So size checker. going to disable this. I can always come back to check the size. All right, now we are going to create around like some houses, random houses around this terrain. So for that, we are going to for loop again. I'm going to do a little bit fast. Int I 0, I smaller than maybe 50, I plus plus. We are going to loop 50 times of instantiating this house object. So instantiate the base house objects within our position and location. So let's create those vectors first. Vector 3. You can copy paste from the parametric wall script while I'm typing. The new vector 3 something. We will add something here. Obviously, I'm going to make some random values, and we need the quaternion identity. Rotation is quaternion identity. So we will give no rotation for now. Okay. Then we are going to instantiate this with position and rotation. Okay, so we are going to create an under this transform. We are going to name this one as current house, which is a game object. This game object will have some rotation later. Okay, I'm going to not do this yet. First, I'm going to create some random value around the size of the minus 85 to 85, because our range was 170, right? So the randomness is done like this. Random dot, we're going to create a range of randomness from minus 85F to 85F. And for height, let's see what is the height. We can also check from the size checker. Let's use this one. So let's move this one a little bit on the sky, and that's around 40. Yeah. So we are going to, for now, just create a hovering on the sky first. Okay. So we are going to make 40F. And the range of Z should be the same as this. So Control C, Control V. Save this. And if I play now, I have created 50 of random positioned houses on the sky. Now, what we are going to do is, at least we are going to find a position that these houses can snap to this terrain. Okay. Before we have to do that, we have to use the sample site. We have just imported our site mesh. So one thing we need to do in order to be able to read whatever we imported from outside, we have to enable reading. So in the models, in the sample site, you have to go to the model and tick read and write enable. You have to tick this and apply. So if you want to use any information from the terrain model that you imported, you need to make sure you tick this. We have struggled a lot with like just a lot of errors just because we forgot to enable this. So make sure you do that. We have to do that for the image as well. If we are going to read the image, go to the image and read and write enable in order to read the color information. So say apply. So do that before you forget. All right, so actually what we need is actually, you can see that when we drag this site model, there is this parent and this default, and actually what we need is this mesh renderer components and this mesh filter. This parent doesn't have anything. So to be honest, what you can do is you can right click, say unpack prefab, so it becomes yours, you can edit it, and just drag this default, the actual terrain model out, and this empty parent, you can just delete it. And just default, you can name it like terrain. Or you can say my terrain, something like you can remember. And in order to be able to read the information, we are going to use raycast as a method. In order to use that, we need to add a component called mesh collider. We just need to have that component in order to be able to read the information. That's it from the preparation from Unity side. And let's go back to our script. Okay, we're just going to write this line by line. Just follow me, and I will copy paste this script after I write this. So what we have to do. Hello?
Yeah, so I just had I get an error when I try to put the script onto random city.
Get an error? Do
yeah,
you see that this is also random city? It's the same name as your file name?
Oh, okay. That's probably one.
Okay. Yeah.
All right, thank you.
It's possible that you maybe made it with different name, changed it. You may need to make sure that this is always same as your file name. Okay.
Gotcha. Thank you.
No problem. What we are going to do is we are going to create a function. Yeah. Don't worry too much. So just follow me. So what we are going to do is we are going to create a function called it's a private function. This is a private, it's a syntax for making a function that returns a vector 3. And we are going to name this saying project point on terrain. Project point on terrain. So this is erroring for now because we are not returning anything. So don't worry. So this name can be anything. Just make sure that you will use the same. Okay, what we are going to do is we are going to also use a import value. Let's say called point. And we are going to return the point like this. So now we don't have any error. So what we are going to do is we are going to pass a point and return, do some calculation. And this calculation is something that is new position that is snapped to the terrain using a function called raycast. Okay, so we are going to use something called raycast. Raycast is a thing that it shoots a ray, like a gun, from a geometry, from a position to a certain direction. And when the vector hits something, it returns that information. All right, so it's really handy. What we are going to do is from those random boxes, random houses we generate, we are going to create. So from these boxes we generate, we're going to create a ray that shoots down. And whenever you shoot down, it will hit the terrain, right? And whenever it hits, this raycast will give you some information about the position of the terrain and the color information of the material. Okay, so it's really handy. So we are going to use that. It's called raycast. Hit. Just follow me. Yeah, and we have to create a ray, the new ray, and we are going to need the original position, which is on the sky, the original house position, and a minus vector that is shooting down. And vector 3, actually vector 3 down vector. The down vector and times like a big number, just to make sure it's not short. Okay, yeah, and we need the terrain geometry. Okay, but we don't have it here, so we need to import it. So for now, say public game object and say terrain mesh. Save it. And in my random city, so we are going to use my terrain and drag that to terrain mesh. Make sure this terrain mesh has the mesh collider and reading enabled. Now this terrain mesh, it can be used for the cast, raycast. And then we are going to make you can make a collider called collider and use the terrain mesh dot get component collider, mesh collider, which is what we just made.
Hey, Somin.
Hey.
Sorry. Where did you add the terrain mesh to? Or it was to the random city, right? And you just dragged it.
Yeah. So I made a new public value here.
Yeah.
And drag the terrain mesh into the random city.
Gotcha. Yes. Thank you.
Okay. Now say if the collider has a hit, say ray out hit, and some value, and the point is hit point. So this actually does the entire calculation and then projecting the terrain and it returning the calculated terrain, calculated position on terrain. So we need to call this. So instead of using the position here, what we are going to do is, so after this, so let's say vector 3 is position on terrain is a projected position using the original position. So this is now calculated from here. And then instead of using the position to rotate it, we are going to use this new position. Let me know if this makes sense. Now you can see that all the houses are actually snapped to the mountain. Now they are snapped correctly to the mountain. Does that make sense? Now you can also change the random city base house to house prefab or house, original house model. So they are snapped in the position.
Hey, so are the random houses being generated above the terrain? That's where you shoot it down, or how does it?
Yeah.
Okay.
Yeah, so these are new position. We created the random houses on the sky and calculated the projected position and then use that position to instantiate it.
Okay, cool. And when you write when you have like void start, that's just running the functions, right? Like if you put like the private function underneath, it's just gonna go to void start, and that's where it runs everything.
Yeah, because we are calling this here for 50 times.
Oh yes, but when if you want to run it in Unity, you always have to put the functions under void start or like under that.
Oh, anywhere inside this parenthesis.
Oh, okay, gotcha.
Yeah, so they are in same hierarchy. This is one function, this is one function, this is one function.